Hello, class. We're moving on to the Trig lectures for section 4.2, and there will be three main subject matters that we will discuss, and here they are. It's the addition and subtraction formula. The first thing I'm going to show you is a little archaic, but kind of a fun little trick using these formulas. But we will be using the addition and subtraction formulas for proven identities as well. So to be able to get a feel for them is good. Evaluating expressions involving inverse trig functions. And then this form of A sine of X plus B cosine of X and how things get simplified by using that. That's an important one for those of you heading into some electrical engineering and working with sine waves and the electrical grid. So what we'll focus on in this one is this addition and subtraction formulas. If you looked at the basic identity sheets that I've uploaded, it's under sum and difference formula. So sum means addition, difference means subtraction. So each book calls it a little bit different. But the formulas are exactly the same. It's like, whoa, look at all those. And again, the ones that are used the most are the sines and cosines. And this idea of being able to take two angles and split them up inside of a sine or a cosine or a tangent wave into two more common angles, especially when these types of calculations were a little bit more difficult without all the technology we have. It was a useful exercise. So what we're going to do is walk you through a couple of these and kind of explain to you how to get an exact answer without using your calculator. And that's the key to this one. And so let me pull up the whiteboard and let's walk through a couple of these. Okay. And as I said, you'll think that this is really archaic, but welcome to Trig. So say like you had cosine of 75, and everybody, including myself, would just get my calculator out, and you would get an answer. And if you did that, let me pull out my calculator real quick. 75 cosine, it looks like it would be 0.2588. And that should be fine in most instances, but this is this theory of using the addition, subtraction, or on the other sheet, the sum and difference formulas to get an exact answer. So the strategy is, we had there we go. So we had this table back here, which had exact values of sine, cosine, tangent for 0, 30 degrees, 60 degrees, 45 degrees, and 90 degrees. And so you're looking to find two angles that either add or subtract that will give you one of those values in whatever quadrant you're looking at as well. And so hopefully this one looks pretty straightforward, right? And it's kind of a puzzle because once you set this up, you could see that 45 and 30, which is two of our key angles, equals 75. And then you get out your sheet and you look at the sum. And so let me write this one up here. And I'm going to say x equals plus or minus y equals cosine of x cosine of y minus plus sine of x sine of y. So how does this work? Well, you have to assign variables. So let's say x equals 45, right? And y would equal 30. And so this is a plus, so it would be the top one. So when you do this, plus here would imply a minus in between here. So if you set this up, it would be 45 plus 30. And that would equal cosine of 45, cosine of 30, and then minus sine of 45, sine of 30. So now what do? You get out your table and you put the exact values that you find in the table for these. So cosine is 1/2 here. No, that would be square root of 2. Let's start over. Jumped the gun there. So this would be square root of 2 over 2 for cosine of 45. And cosine of 30 is square root of 3 over 2. And then you would subtract sine of 45 square root of 2 over 2. And sine of 30 is 1/2. How do we set this up with regards to this? Well, we do have a common denominator. So one of the things that you could do is multiply these all together. That would be the next step. So square root of 2 times square root of 3 is square root of 6. And then 2 times 2 is 4. And then you would subtract. Square root of 2 times 1 is square root of 2. And here you would have 4. So you see we have a common denominator. So you would put those together. And that would be the answer. Pretty archaic, I agree. But the idea is that when you walk through these, it gives you a feel for how these work. And you'll see that when we get to the next few sections, we're going to be using these as proofs, or these identities to help us prove things. And so the understanding of how to work these is important. So let's do one more example. And so let's do one in radians. So how about we do cosine of pi over 12? You know what? And that's what we have in here. Let's do the one we have in the book. That would be the best one. And so if we set this one up now, I would convert it to degrees. So what would you have? 180, 12 divide, and that would be 15 degrees. So you see that you can't do the addition part now because the smallest angle we have is 0 and then 30. So if you think about it, what two angles, if we subtract, will give us 15. And so in this case, it would be cosine of 45 minus 30. See how that works? And so when you set this up, it would be cosine of 45, cosine of 30. And then because there's a minus in here, this one would end up being plus. So this would be plus cosine of 45, cosine of 30. And so you can see we're plugging the exact same numbers in. And there's a reason why I'm doing this one, just to kind of show you something here real quick. That would be 1/2, and that would be that. So when you do this again, instead of having a minus here, oops, 2 times 2 is not 2, 2 times 2 is 4. So remember we had cosine of 15 degrees equals, and then if we had cosine of 75 degrees, it equaled almost the same thing, except we had a negative, right? And what's interesting, if you take a look at this slide, it kind of shows you how these things start to become interrelated, right? We made this idea that cosine of pi over 2 minus u equals sine of u. So you can prove this now using the addition subtraction formula. And you can see that when you take a look at these different angles, and if they're 45 degrees or 90 degrees apart, you'll see that there's some symmetry involved with it as well. So that gives you an introduction to the sum and difference or addition subtraction formulas for Trig. The next one, we'll move on to the next section, which would be inverse trig, solving inverse trig functions.